Now, let's talk a little bit about the enzyme aldolase. Aldolase is actually fructose bisphosphate aldolase. It is an enzyme. It performs that reversible cleavage reaction going from the fructose 1,6 bisphosphate and breaking down the 6 carbon chain into a 3 carbon chain, producing DHAP, which is the dihydroxyacetone phosphate and glyceraldehyde 3 phosphate. So as you can see here, this enzyme actually can catalyze the reverse reaction and the forward reaction. It actually sits close to equilibrium and is able to switch back and forth. So we can go from 3 carbon chains in this direction to produce the 6 carbon glucose through gluconeogenesis, or we can actually go backwards, well, not backwards, I guess mainly forwards, as most people would think. The forward direction is the one that we're most familiar with, going from glucose through glycolysis and then cleaving that 6 carbon chain down into the 3 carbon chain. So aldolase actually is a very versatile enzyme and is super important for our metabolism and keeping, either breaking down sugar so that we can make energy, or if we need sugar, it can also do that as well. Now, aldolase actually comes in 3 different forms in vertebrates. They differ based on their location in what tissue, their kinetics and how fast they work, as well as their different developmental expressions. All 3 of the different aldolase isoforms have the same overall folds and active site structure. They just happen to be in different locations. So aldolase A, this is found in high energy demand tissues, including muscle tissue, which is both skeletal muscle tissue as well as cardiac muscle tissue. Also found in red blood cells and in embryonic cells that need glucose at a very high rate. Aldolase B is what we're also going to talk more about a little bit later. Is also found in liver, kidney, and small intestine. It deals with liver glycolysis as well as gluconeogenesis that takes place in the liver, and also some fructose metabolism. As we know, fructose can also be converted to glucose through a series of chemical reactions. Last but not least, we have aldolase C. This type of aldolase is found more in the brain and the tissue containing neurons. This performs brain-specific glycolysis. So as you can see here, not all 3 of the aldolase isoforms are able to do gluconeogenesis. A, B, and C can all do glycolysis, but aldolase B is the only one that's capable of doing the gluconeogenesis.